Hi everyone. Oh, thank you. If you want a digital copy of the handout, it's on my website there. So, full disclosure, I really don't know if I believe the arguments that I'm presenting here. I'll read what I wrote in favor of the argument, and I'll think that it's definitely right 100%. And then I'll read the objections that I wrote towards it, and then be utterly convinced of those. And so I think, not to undersell what I'm doing, but I think a lot of the value is trying to articulate this view or argument that underlies a lot of discussions in the Metaphysics of Ordinary Objects literature. This is kind of a metaphysics paper where I try to show that science also are. So in this paper, I'm going to try to show that there is no what I'll call faithful reconstruction of science without composite objects. So I'll do this by providing an objection to some existing composite object dispensability arguments. And so I think my argument is novel in the sense that it leverages compositional explanations of properties that are used in evolutionary biology to show that these composites are indispensable. So people who are sympathetic to a science without composites will have tools to paraphrase objects away, but I'm going to show that these face some significant difficulties. So here's the plan. I'm going to be offering an indispensability argument, taking cues from the indispensability argument for the existence of numbers. So Hartree-Field tried to show that we can do a science without numbers. I mean, a portion of an outdated physics theory without numbers, but that's okay. I'm going to try to show that there's no science without composites. That's the idea. So in order to do this, we have to see how philosophers see dispensability and indispensability, and then I will give the science without composites view, and then I'll offer my own objection to that view. Okay, so indispensability arguments. Indispensability arguments aim to show that appeal to some entity is essential to a mature, successful scientific theory. The idea goes that these entities are essential when every adequate formulation of the theory appeals to that entity, usually in the sense of quantification. Almost never does somebody try to show that it's impossible to formulate a theory without appeal to some entity. Putnam tries this and it does not succeed. Instead, what happens is entities in these mature, successful scientific theories are innocent until proven guilty. They're accorded a sort of provisional indispensability until somebody comes along and tries to dispense with that entity. Right? The idea is science isn't in the business of putting forth, postulating a bunch of unnecessary entities. We think that they generally got it right. So conversations then proceed by somebody trying to provide a potential dispensing theory and then see whether it succeeds. I think this is what happened in the entirety. There's been two sort of arguments in the indispensability argument for the existence of numbers. This is how the literature has proceeded in both. Somebody says, here's my dispensing theory to get rid of numbers, and then a bunch of people say, no, that doesn't quite work for whatever reason. Okay, so why do indispensability arguments matter? They matter because a lot of metaphysicians of science use them to help us inform our ontological picture of the world by means of the following principle, which I labeled on the handout. So it's called the indispensability principle. We ought to ontologically commit to all and only the indispensable entities of our best scientific theories. So plausibly, this principle is justified by some form of scientific realism or naturalism or something like that. I'm not going to go too deep into that. I'm just going to assume the principle because it makes it really simple how this argument is supposed to work. It's controversial, especially the only direction. We should commit only to indispensable entities. You might want to weaken that and say something like, well, we have some defeasible reason to not commit to dispensable. But that sort of complicates the picture. We're going to do a nice clean version. It shouldn't change things too much. Okay, so for these principles to do any sort of work whatsoever, we need to know what it means for something to be dispensable or indispensable. The consensus from the mathematical indispensability literature is that an entity is dispensable to a scientific theory when we can provide an alternative theory that is attractive enough, does not appeal to that entity, and preserves all of the important scientific content of the original. So this is found on the handout under the definition of indispensable. An entity X is dispensable to a theory T if and only if there is a theory T minus that does not appeal to X's, is suitably attractive, and preserves all of the important scientific content of T. The condition that I'm going to be concerned with here is the third condition, so keep an eye on that one. Okay, so science without composites. So the question that I'm working through in this paper is whether composite objects count among the indispensable entities of those theories. Right? After all, our best scientific theories, in fact, do reference tons of composite objects. Bars of iron, stars, minerals, pieces of cork, all of these things are referenced in our best scientific theories. Not even to mention organisms, organs, these sorts of biological things as well. Some people have given arguments that just try to take this at face value, say, well, our theory references bars of iron, therefore they're indispensable. People like Timothy Williamson has said this, Thomas Hochweber, Alex Byrne, all of these sorts of people. I have a paper criticizing them. I think it's a little too simplistic. But a lot of people think that this reference to composites is accidental and inessential to the theories. They would opt for a science without composites, or SWC, a group of theories that will eliminate any reference to composite objects in our theories. This view really gets its bearings from a bunch of analytic metaphysicians. Van Inwagen, Kian Dorr, who else? Trenton Merritts, these sorts of people. Ted Sider has a paper before he recanted on this. The idea is we don't provide a literal translation of our theories. Instead, we provide a translation scheme where you take any one of our theories, plug it into this translation scheme, and you get a result that is a theory that does not appeal to composite objects. Here's the translation scheme. I have it on the handout as well. Take one of our best scientific theories, T, replace all appeal to some composite X in T with appeal to mereological simples arranged X-wise, and replace all appeal to some singular property P that's in T, realized by composites, with appeal to a collective property P minus, realized by simples arranged composite-wise, and make no other changes to the theory. So you're probably familiar with the procedure of paraphrasing away composite talk in favor of this simples arranged X-wise talk. This is Van Inwagen's classic strategy. But you might not see why we have to worry about properties. So we're going to do a bit of a detour on the property stuff. There's really not a lot of work from these metaphysicians talking about properties, which is kind of sad so I had to do this all myself, in other words, which was not fun. So I provided a table to help track this. But here's the idea. A singular property, in my sense, is defined as a property that can only be borne by a single entity that is not itself a mereological symbol. Like the property of being read all over. A single ball can have the property of being read all over. A handful of balls cannot have the property of being read all over. Okay, if some scientific theory appeals to a singular property, that means it's not predicable of the mereological symbols. Then, if that property is realized, this entails the existence of a composite object. So that's the sense in which I'm using a singular property. So, if a scientific theory entails that something is read all over, then that theory cannot be part of science without composites. So that's why we have to replace singular properties with what I call collective properties. But there's a complication. So, three kinds of properties can be had by collections of things. There are what I call pure collective properties, which can only be had by collections of things. The most obvious case is the arranged X-wise property that people talk about. But it also includes some scientific properties, plausibly, like conductivity, which is a property that is had by multiple atoms when they are arranged in a particular way. Conductivity typically is characterized as a property of materials, which are conceived of as arrangements or structures of molecules or atoms. So it's the arrangement which has the property of conductivity. These properties can be straightforwardly adopted by science without composites. The second kind of collective property is what I call mixed collective properties. These can be had either by individual entities or by collections of things. My example here is the property of orbiting. So one thing, a moon, can orbit a planet, or a scattering of debris, a collection of debris can orbit a planet. So I think SWC, Science Without Composites, can straightforwardly translate those mixed collective properties and just say, oh, it's had by the symbols. Okay, finally, there are some properties that can be had by a collection of things, but only in virtue of that property being had by a single thing. So these are what I call disguised singular properties. So take acidity. We say that a solution, which is some collection of molecules, is acidic. But this is only in virtue of individual molecules that are acidic. So if we have a disguised singular property in our theory, this entails that there is some non-simple bearer of that property, and so SWC has to get rid of it. So the basic upshot is, if there are singular properties, Science Without Composites has to get rid of it, and if there are disguised singular properties, they have to get rid of it. So let's see how this works in action. So suppose we have a scientific theory which entails this consequence, which I'm calling ordinary 1 or O1, the iron bar rusted. This is our whole theory. Nice and simple. This consequence appeals to composite objects, iron bars, and it appeals to a singular property, rusting. Right? So this property is only had by composite objects because rusting is a diachronic property, happens over time, where some one thing undergoes a chemical transformation. So what SWC is going to do is they're going to transform that consequence into SWC1. The simples arranged iron bar-wise, rusted minus. Cool, nice and easy. So the property rusting minus is a collective property that mereological simples possess when they quote-unquote rust. It's actually really sophisticated how this works, and there's been some objections to diachronic properties, but we're not going to go into those. So strictly speaking, this theory does not entail that anything rusts in the strict sense. According to proponents of Science Without Composites, all of our theories that appeal to composites have replacements formed by this process that do not appeal to either composites or singular properties. So I think the most plausible interpretation of what they're doing is providing a composite object dispensability argument. They're saying, look, yes, our ordinary theories appeal to all these composites, but I can provide you a way of translating each one of those theories into a theory that meets the conditions for dispensing with whatever composite objects are appealed to. So for this strategy to be successful, it has to be that every theory generated by this process satisfies the three conditions. I'm going to assume that each one satisfies the first two conditions, which I'm not entirely happy with. So we're just going to focus on the third condition for now. Okay. Let me take a drink of water while we prepare. Okay, so this version of Science Without Composites is the only candidate composite dispensing theory that has actually been introduced in the literature, like to a sufficient degree. What I'm going to argue is that there are accepted scientific theories of which Science Without Composites does not and possibly cannot provide adequate reformulations of. So I don't intend for this to be the last word, right? Somebody puts up a dispensing theory, somebody else responds to it, and then the conversation proceeds there. I don't even think SWC theorists are going to be fully convinced by what I say. So the basic idea is that I think there are far more singular and disguised singular properties than the SWC proponents might initially suspect. And this makes it really difficult to offer this straightforward replacement strategy. So my argument proceeds by examining compositional explanations of properties. So a long time ago, in the 1600s, Robert Hooke looked at a piece of cork under a microscope. And he presented the explanation that pieces of cork are buoyant because their cell walls are hydrophobic. So what he did there was he explained the property of the composite object, the piece of cork, its buoyancy, in terms of the properties of its parts. The cell walls. So my indispensability argument takes these compositional property explanations as crucial parts of the scientific image. So let's see this in action. Here's my example. Ferromagnetism is the property of a material to have non-net zero spontaneous magnetization. So it differs from these other kinds of magnetism in the sense that it always has a net positive or net negative spontaneous magnetization. Ferromagnetic materials do not need to be magnetized like nickel does. Ferromagnetism arises from a mineral having opposing magnetic forces that are unequal in magnitude. So there are many different kinds of minerals that are ferromagnetic, including magnetite, one that's called gregite, yttrium, iron garnet, and so on. There's a ton of them. As the name suggests, all ferromagnetic minerals have iron in them, but the arrangement of the iron atoms and the other atoms that are present in the mineral differ with each one. So, for example, magnetite is comprised of iron and oxygen in octahedral crystals and opposing tetrahedral crystals. These opposing crystals give the mineral an unequal and opposite magnitude so that it's naturally magnetized. Gregite has a different structure. So the compositional explanation of ferromagnetism, a la Hooke, is this. Magnetite is ferromagnetic because its iron atoms and oxygen atoms are opposed in particular crystal patterns. So we explain the property of the mineral in terms of the properties of the parts of the mineral. The idea is different microphysical structures give rise to ferromagnetic substances, or that it can be compositionally explained by different kinds of microphysical properties. So here's my argument. It's on the back. Premise 1, the property of ferromagnetism is indispensable to some of our best scientific theories. Premise 2, if so, then composite objects are indispensable to some of our best scientific theories. 3, so composite objects are indispensable to some of our best scientific theories. Valid argument. Nice, we're good. We made it halfway there. So the basic idea behind the argument is this. When we look to our best theories, we see scientists appealing to very different kinds of magnetism to explain different empirical phenomena. Some of these empirical phenomena are explained by appeal to some mineral being ferromagnetic. So at first glance, ferromagnetism is indispensable. It appears in our best scientific theories. It seems to actually be doing some work. Premise 2 gets its justification from the fact that ferromagnetism is either a singular or a disguised singular property. So if these two premises are true, then we can conclude that some composite objects, at least certain kinds of minerals, are indispensable. And I think that the spirit of the argument shows that there are tons of natural composite objects. Okay. So I'm going to consider a brief objection to premise 2 and then a lengthy objection to premise 1. So the brief one to premise 2 is that you might argue that ferromagnetism is not a singular property at all, but instead some sort of collective property. I think it's useful to see why it actually, as it appears in scientific theories, is singular. So ferromagnetism is always predicated either of a single mineral or of a mineral chunk, which we might think of as a collection of individual minerals, spatially arranged with certain covalent bonds, all that stuff. So ferromagnetism seems to be predicable of collections, at least, right, if we think it's a mineral chunk. But some properties are disguised singular properties, and I think that's what's going on here. Ferromagnetism can't be a property of simples because ferromagnetism necessarily requires an entity with an internal structure of these opposing magnetic forces. So ferromagnetism, as it's used in contemporary science, is a singular property, and so it needs to be excised in science without composites. So let's turn to the main objection. So you might object to my argument as follows. You might say, well, look, premise 1 claims that ferromagnetism is indispensable only if we have this ultra-literal interpretation of the science. Is this going to be true? Instead, we can just do away with it with the standard process of getting rid of a singular property with some collective property, as outlined by the SWC theory generation procedure. I'm actually pretty sympathetic to these kinds of arguments. I think that a lot of things that metaphysicians try to glean from scientific theories are pretty bad. And so I think it's often a matter of convenience that we appeal to the sorts of things we do in scientific theories. But I think ferromagnetism is different. So the strategy, the idea behind the strategy is to do what I call a simple elimination of ferromagnetism in favor of this ferromagnetism minus. So I think it's useful to walk through this carefully. So suppose our ordinary scientific theory now had two consequences instead of one. We've got O1, this magnetite mineral is ferromagnetic, and O2, this greigite mineral, is ferromagnetic. So SWC takes theories like this and flattens them across levels of explanation, reducing all composites to simples and arrangements, and all singular properties to collective properties of simples and arrangements. So there's a problem with this initially. So consider the translation of O1. SWC replaces appeal to magnetite with appeal to simples arranged magnetite-wise, and it replaces appeal to ferromagnetism with ferromagnetism minus, this property of simples when they are arranged magnetite-wise. So we have the following, O1 minus. These simples arranged magnetite mineral-wise are ferromagnetic minus. So something to note here is that ferromagnetic minus is a property had by simples when they are arranged magnetite mineral-wise. This property arises out of specific physical interactions between iron atoms and their neighbors, producing these particular magnetic moments. So the exact arrangement and properties of simples that make up magnetite realize ferromagnetism. Okay. But because magnetite and greigite involve different atomic constituents, iron and oxygen rather than iron and sulfur, they produce different magnetic interactions and moments. At the level of simples then, it does not seem like we can say that simples arranged greigite-wise bear the exact same property of ferromagnetism minus. Right? So if we try to do O2 minus, these simples arranged greigite-wise are ferromagnetic minus, I think is false by SWC's own lights. So the simples arranged greigite mineral-wise are not ferromagnetic minus, since that property can only be had by simples when they are arranged in the particular way that magnetite minerals are arranged. Iron and oxygen in these octahedral and rosy tetrahedral patterns. Okay, cool. So far there's no real problem for SWC. What they're going to do is they're going to say, fine, you're right. There's no ferromagnetism minus. What I'm going to do instead is I'm going to introduce two properties at the level of simples. What we'll call G ferromagnetism and N ferromagnetism. These are different ferromagnetic properties at the level of simples. So the strategy is to say, there's no such thing as ferromagnetism, but there are things that look just like it. When simples are arranged magnetite mineral-wise, they are M ferromagnetic, and when they're arranged greigite mineral-wise, they are G ferromagnetic. So I think the proper replacements of these are SWC1 and SWC2 on the handout. Is that the numbers of them? 2 and 3, sorry. Okay, so SWC has a strategy for providing these seemingly adequate alternatives to our ordinary scientific consequences. So, consider whether this formulation preserves all the important scientific content of the original. I concede that all of the empirical content between these translations is preserved. But I think that there is important non-empirical content that is not preserved. And so let me try to articulate what that is. So I think that ferromagnetism itself plays an important explanatory role in evolutionary biology. So there are these bacteria called magnetotactic bacteria. They're really cool. They create organelles out of minerals that bias the organism's direction to the north-south pole, and they do this to be able to travel. They can only travel in a straight line, but because they create these magnetic organelles, it wrenches them in a direction, and so then they travel to places with better oxygen or whatever. For a long time, we only discovered bacteria that create these organelles out of magnetite. And scientists proposed the explanation that the bacteria use magnetite because magnetite is ferromagnetic. It preserves its magnetism even after the organelle transformation process. But we learned in the 60s that there's a ferromagnetic mineral that has a different compositional structure than magnetite does, which is greigite. And greigite is used by some magnetotactic bacteria to do the same thing. So bias the bacterium's direction on the north-south axis to get it toward places with better oxygen. So our scientific theories, I think, have concluded that what is important for the magnetotactic bacteria is not this particular substance or that, but that the substance is ferromagnetic. That's the key part of the explanation. So my claim is that any adequate reconstruction of our best microbiology theories will include the explanation that these different magnetotactic bacteria use different substances for the same process because those substances are ferromagnetic. So I don't think this is just an empirical claim about what bacteria do. It's a claim about what explains their behavior. So ferromagnetism as this unified property that can be realized by different mineral structures, is indispensable to explaining why distinct species of bacteria converged on the same solution to the problem of magnetotaxis. So the theories that are generated by SWC, I claim, cannot preserve this explanatory context. By replacing ferromagnetism with this M ferromagnetism and G ferromagnetism, SWC, I think, obscures the unity that makes this explanation illuminating in the first place. Right, the fact that these different bacteria use either greigite or magnetite is explained by ferromagnetism being a particular property, not by having its own distinct, not by each mineral having its own distinct magnetic property. So I think SWC fails to generate theories that actually preserve all the important scientific content. Okay, like I said at the beginning, I don't take this to be the last word on the matter. I do think that it provides some reason to think that the straightforward route of dispensing is just reducing all of the singular properties to the properties of collectives does not do well enough in preserving the sort of unifying explanations that we see in science. I could say more. I don't think I'm going to say more. I think that's all I got for you. Thank you very much.
Yeah, go for it. Up and download that.
Yeah. Is it showing? No. Oh, I know what it is. It's something like that.
Oh, yeah.
I clicked notes, so do you have to press on it?
Okay, at some point the QR code will appear. You can have a look at the mini handout for these comments, but I'm mostly going to comment freely, but maybe after you can also have a look at the handout if you want to. Obviously, completely optional. Okay, so I'm going to start just because I reckon I'm only given 5 minutes, so I'll try to keep it brief. Yeah, hang on a second. So I wanted to thank Alex, of course, for the wonderful talk and paper that I had the pleasure to read. But honestly, don't worry about it if it doesn't show. Okay. Never mind. Yeah. I'll try to be clearer. Yeah, thanks, Alex. It was a wonderful presentation. I really enjoyed the paper too. I think it's making some strides towards a project that I'm very sympathetic with, which is, of course, Alex is arguing that dispensing with reference to complex objects isn't such a good strategy at all. I imagine that the step forward would be the more constructive part of the project would be trying to figure out whether dispensability is a good reason to determine which complex objects we should be committed to in nature. That's something that I think could be a powerful and fruitful avenue of research. Since I'm only given 5 minutes, as Alex knows, I'm going to raise 2 questions. The first concerns premise 2 of his argument, which is the one you see on the second page of his handout, composite object indispensability argument. So the second premise is that if the property of ferrimagnetism is indispensable to some of our best scientific theories, then composite objects are also indispensable to those theories. His motivation for thinking that premise 2 holds is that the best scientific theories he has in mind are theories that predicate ferrimagnetism to entities with internal structures, such as pieces of mineral, like he brilliantly put it in his presentation. So I was wondering whether that motivation is enough in this context for thinking that something like a complex object, so like a sun, is indispensable to those theories. Because I was thinking that if we wonder whether the motivation could be for thinking that predication of ferrimagnetism to an entity with an internal structure is sufficient for thinking that that entity is complex, then what makes it sufficient as motivation? In this context, obviously, we cannot appeal to the fact that the property of ferrimagnetism is singular, because the singularity of the property presupposes that the entity that bears it is complex. So that would give us a circular argument. And we can also, at least that's my feeling, when we see that the theory predicates ferrimagnetism to an entity with internal structure, in order to infer that that entity is complex. In this context, we could assume that something like the internal structure of the entity that's predicated the property suffices for compositionality of the entity, but I'm not sure that in this context we could do that. Like when arguing against someone who wants to deny that the entity in question is complex and say that it's got internal structure but it lacks compositionality. I was reminded of a book that you might be familiar with called The Structure of Objects by Catherine Kozlitsky, 2008. Where she argues that if we want to figure out what complex entities exist in science, we just look at the natural kinds of objects that scientists seem to refer to, and we try to determine if they have internal structure. And if they do refer to entities with internal structure, then we know that that internal structure suffices for compositionality, for the compositionality of the entity referred. But she uses that kind of argument to demonstrate that we want to be selective about which composite objects exist according to best science. So, for example, we could say that water molecules exist and are composite, but the scattered mereological sums do not exist because they're not referred to under the label of a natural kind in the best scientific theory. But she doesn't use that kind of argument to argue against nihilism. So she doesn't say that that we should think of the water molecule as a composite as opposed to a structured symbol, if you want, but not a sum. So maybe you have something to say about that, whether we can assume that internal structure suffices for compositionality in this context. The second question refers to the first part of his objection 1, which you can also see on the second page of the handout, So Alex argues that the two paraphrased versions of O2 and O3, so O star 2 and O star 3, cannot both be true. They rule each other out, because they predicate this property of being ferromagnetic minus. And the reason he gives for thinking that only one of these two paraphrases can be true, but not the other, is that, according to Alex, being ferromagnetic minus is a collective property, so it applies only to a collection of simples, not to a composite object. But it only applies to collections of simples that realize or exemplify atomic interactions of a precise nature. So in this case, for example, simples arranged magnetite mineral-wise and simples arranged rigide mineral-wise realize different types of interactions between the simples. So since being ferromagnetic minus requires them to instantiate only one particular type, it can't be that both simples arranged magnetite-wise and simples arranged rigide-wise have this property of being ferromagnetic minus. So the two theories must exclude each other, must rule each other out. So my worry is there, why exactly we need to think of being ferromagnetic minus as a property that can only be instantiated by a collective of symbols that exemplifies atomic interactions, internal interactions of only one particular kind. So, why not think of being ferromagnetic minus in terms of multiple realizability, so multiply realizable by distinct collections of symbols? I don't see a barrier here, because we could have multiply realized properties of collections. So, for example, being ferromagnetic minus could be instantiated by simples arranged magnetite mineral-wise, and also simples arranged rigide-wise, so long as it's realized by the iron-oxygen interaction in one case and the iron-sulfur interaction, exemplified in each of these two different collections of simples. So on these conditions, the dispenser, the person Alex is arguing against, who wants to hold O star 2 and O star 3 together, could regard them as both true, not excluding each other, because the ferromagnetic could be understood along these lines. Other than that, I really enjoyed the paper. I have myself some work on scientific composition, and personally I think Alex has made steps forward in this direction, and we gave me a lot of food for thought. So thank you so much.
Are we done? 20 minutes from now? Yeah. More or less. Okay, cool. Thank you, Fabio. That was really nice. So there were two questions. I'll try to go quickly through this, but annoyingly I have a lot to say, so I'll try to skip whatever is possible to skip. Annoyingly for you all. Yeah. So the first question is something like, why can I assume, more or less, that ferromagnetism is a singular property, in the sense that it entails the existence of composites, if it's realized? Why not think that it's a property that can be predicated of simples that are arranged into some structure? So here's the thought. This sort of is a big picture thought. I'm trying to offer an indispensability argument. Somebody who's not in this business might take a compatibilist look towards our scientific theories and say, like, yes, I understand that it looks like our theories quantify over composites and all of that, but really the theories are consistent with or compatible with the non-existence of composite objects. And such a person would think that maybe ferromagnetism is just a property of simples in some structural arrangement, and indeed that magnetite is just simples in that arrangement as well. That what magnetite is this collection of simples. However, SWC theorists and myself are not entirely happy with this interpretation. Not that Fabio was endorsing this interpretation. the idea behind indispensability arguments is we look to our theories and we take them roughly at face value, and then ask of them whether each part is indispensable. And so the SWC proponents themselves think that our ordinary scientific theories are rife with composites and singular properties, and that they do need to replace them. And so I think that the SWC theorist is somebody who would agree that ferromagnetism is a singular property, and they want to get rid of it. So I don't think they'd be entirely happy with saying it's consistent, that the theory is consistent with no composite objects existing. Maybe that doesn't satisfy you, but that's just the general idea where I'm coming from. Okay. So the second question, I think, deserves a much longer treatment. Here's, I think, the basic idea. This is, in fact, the second half of my paper. It's not fully complete yet. But the basic idea is we should see that ferromagnetic minus is a sort of higher level property of simples and arrangements, in the sense that it's multiply realizable by simples arranged in different ways. Simples arranged Greigite-wise, simples arranged magnetite-wise, and so on. There are different specific mechanisms for how someone might pursue this. They might say that, well, ferromagnetic minus is this disjunctive property where we have M ferromagnetism, G ferromagnetism, and all these things as disjuncts. Or it's a determinable and N ferromagnetic is the determinate, or so on. There's different ways that you can do this. I have two thoughts on this. I'll go through them quickly. The first is that I think this idea of having properties of different levels is sort of at odds with the spirit of science without composites. SWC wants to say that it appears that our theories require this physical world with all these different levels of explanation, from atoms with atomic properties to cells with cellular properties to organs with functional biological properties and so on. But that this is mere appearance. That's what the SWC theorist wants to say. They want to say there's only simples and their particular properties. Sometimes the properties of simples are irreducibly collective, but we can ignore some of those. To say that ontology is flat, but ideology, the properties that we have, is as rich as the ordinary theory says, is sort of odd, I think. There's sort of something weird going on. But that's not an objection, that's just an ickiness. The second main objection I have to this idea is that I worry that this response trivializes the explanations that inspired Robert Hooke. So Hooke said that cork floats because its cell walls are hydrophobic. Material scientists claim that magnetite is ferromagnetic because its iron and oxygen atoms have this particular structure. I think this is an illuminating explanation. We understand the higher level properties as being explained by the properties of the parts of those things. But I think when we replace this explanation with this ideologically rich SWC, we might trivialize the explanation. Because what we result with is something like, sorry, this is going to feel a little annoying, but this will be the last thing I say. Simples arranged magnetite-wise are ferromagnetic minus because the simples arranged magnetite-wise are M ferromagnetic. I think that's the explanation that somebody would have to give in this circumstance. Which is sort of like saying the ball is red because the ball is maroon. I think there's something trivializing about that. I think it doesn't meet what was revolutionary about Hooke's explanation. It's not fully worked out, but that's my main thought, is that we get some explanation trivialization. And in doing so, we lose out on important scientific content. But yeah, thank you very much. Those are really good comments.
Thanks, Alex. If you have a question, please raise your hand. I will point at you and give you a number, and you need to remember your number because I'll probably forget. Start over the other side. One, go ahead.
Shall I wait?
Oh, go ahead.
Oh, thank you. Thanks so much for this. This was really nice and clear. So I was wondering, I'm largely sympathetic to your view. When it comes to N ferromagnetic and G ferromagnetic at the end, your thought seems to be we lose some explanatory content in not into a singular property that can unify those two different properties. And I wondered, you said you could say more sort of about how the dialectic would go, and I suspect we've already heard some in the commentary there to do with multiple possibilities. But what could the SWC, what kind of line could the SWC proponents go by to say, to talk about how n-ferromagnetic and g-ferromagnetic properties have something in common? Like what ferromagneticness could they have in common other than appealing to a singular property? I guess kind of if you were to give the most sympathetic rendering of the opposing view, maybe it's pretty similar to what we just heard, but I was wondering if you'd say more.
Yeah, I mean, it's sort of hard because the moment we dip our toes into these waters, there's so many, metaphysical concepts that we could appeal to, but they all come with a lot of baggage. But you might want to appeal to a powers view. You can say that there's a certain subset of powers that is shared by M ferromagnetism and G ferromagnetism. I think that would go towards saying why these two theories why SWC is empirically equivalent to the ordinary theories. So any empirical prediction you could make with the ordinary theory, SWC can capture that. But I think that this unifying explanation is non-empirical content that is actually within the theory, and so that's what I think needs to be preserved. Does that make sense?
Yeah, I guess what's the explanatory deficiency then in saying the powers example?
Yeah.
As compared to a singular property.
Yeah.
Why is the singular property a better explanation than...
The thing is, it's not necessarily, I think it probably is a better explanation. But the thing that I'm trying to preserve is that it is the explanation that is given in science. Mm-hmm. And that's what we need to preserve, or something that is good enough. And the reason I'm a little suspicious of the powers thing is because powers talk is tied up with entity talk, and so I'm a little hesitant because I don't know if that fully satisfies.
Thank you.
We can continue talking about this later.
Number 2.
Thank you for the talk. That was really interesting. It's super clear. I really loved it. I have a few related things to say, I guess, against your response to the second comment.
Yeah, the trivialization.
That was the first thing that came to my mind on seeing the final maneuver in the paper. A couple of related things. So, the ideology you allowed the denial of composite objects in science already is not fundamental level ideology, and you're sort of worried about appealing to any non-fundamental level ideology. I'm thinking that properties of ferromagnetism, even if specified to the G and N level, they're not fundamental. So, if you're okay with them appealing to that, why not the more abstract, just ferromagnetism minus? Or were these G and N ferromagnetic things just placed on this sort of truly fundamental?
Yeah, I think the most strict version of SWC would have these be just placeholders for.
Okay.
Yeah.
And you're sort of saying hey, you want ontology to be flat. Shouldn't you want ideology to be flat as well? It's sort of hard to see how ideology could be flat. Aren't there properties of having one or other of these properties? It's sort of, you might think that just comes automatically. Everyone has to admit that there are sort of levels of properties. And moreover, that the methods by which these levels are generated is not composition, so maybe it's okay for people who don't like composition. It's like some entailment sort of thing that works in the way that disjuncts entail disjunctions, and that's not compositional generation, right? It's some kind of generation of levels, but maybe it's innocence with this kind of motion because it's not compositional. And the one final thought, I'm sorry, maybe these aren't framed in terms of questions.
No, that's good.
Maybe they should be, was that you said that the explanation of symbols arranged magnetite lines, for instance, having ferromagnetism minus is going to have to be given in terms of there having M ferromagnetism minus, because the formula is multiply realized by the latter and other things. I was just wondering whether that actually does follow, that the explanation has to work that way. Because you might think that whatever the plural genuses are multiply realized in species. But people tend to think that a species is a genus plus something else. So the genus is involved in the explanation of the species. You remember you're a square in part because you're rectangular, and then there's the equilateral part as well.
Yeah.
And then you sort of have multiple realizability going in one direction, but explanation going in the other. Those are the thoughts. Sorry for.
Yeah, no, good. No, good. I think I'm only going to touch on the second thought and then respond to the third. So the second thought, I do think that properties as used in science are compositional. The entailment, as it goes up, it is compositional explanation. So I do worry about just the claim that it's innocent to have a richer ideology. But that doesn't mean that SWC can't try to provide something. Okay, the second thing. Here's what I was trying to say. So we have this explanation in science. Magnetite is ferromagnetic because it's, atoms are arranged thus and so. The real explanation, whatever it is, right? Because it has iron and oxygen atoms that are arranged in this particular way. The sophisticated SWC replacement would be something like simples arranged, magnetite-wise are ferromagnetic minus because the simples arranged thus and so, P-wise are M ferromagnetic. That's my thought, is that you take this explanation, which is a genuinely illuminating explanation. Magnetite is ferromagnetic because its iron and oxygen atoms have this certain arrangement. Okay, this sophisticated SWC comes along and says, all right, let me give my replacement of that. It's going to be something along the lines of, simples arranged magnetite-wise are ferromagnetic minus. Why? Because the simples arranged iron and oxygen atom-wise and whatever are M ferromagnetic. And this explanation feels trivialized to me. Because what is it to be magnetite-wise? Well, it's to be either M or G or whatever ferromagnetic. Sorry, what is it to be ferromagnetic minus? It's to be one of these disjuncts or whatever.
Yes, that was the thing I was putting back.
Yes.
Okay, sorry, we got it.
Okay.
I'm sorry. We've only got 10 minutes.
Okay, sorry.
We're going to move forward if that's okay.
Yeah.
Okay. So we go to number 3.
Yeah, that's all. I actually wanted to come back to the second point that Fabio raised. Just to take another example, comparing it with the ferromagnetic cases. So you take two bands, music bands. You forget their bands, you just focus on the two collections of people. Both, let's say, are playing a given song, right? They might be composed very differently. They might have, but still they do the same thing. They play. Now, here is the description of the situation. You have these two groups, these two collections, various properties. They produce each of them produces an event or something that has the property of being an instance of anything. Right? So here, there's no funny business of different levels of properties. There's just the event that's produced and the modification. They are instances. Now, going back to the case with the ferromagnetism, the thought would be that yes, you could have these different collections of things arranged differently. They would have a certain type of behavior in certain circumstances, and then you would qualify types of behaviors of each type as being behaviors that correspond to So here again, no funny business with different properties of different levels.
Yeah, I'm getting stuck on the band example because I'm worried that like I want to look to scientific theories, but I don't know if I'm just seeing a red herring where there's not actually one. Can you say one more time what the comparison was? Yeah.
So you have different collections, different properties, different relations on each side, and they end up producing two things, okay, which both count as being an instance of melody. So they both play the same song. So in that sense, they have the same property. But in my metaphysical description of the case, I can appeal to several different.
I see. So the idea is, look, we all know a band is just a collection of individuals. Two different bands could each play the same song. We don't want to say that there's the analog to M and G ferromagnetism in each one. I'd have to think about this more. I'm still getting... I think there's some funny business going on because we know that there is no such thing as a band, that all a band is this collection of individuals. But I think that's a metaphysical presupposition that we bring to the table. And so I still am getting some funny business, but we'll talk about it.
I'd like to go back to what you said about the bacteria. So the general or higher level property of ferromagnetism, you say it is an argument for taking it to be indispensable that it is used in a biological explanation of how these bacteria got their magnetic mechanism. And so you didn't use the word cause or causal. So isn't it in the background that what justifies the indispensability of some property or some type of composite is that it plays a causal role in some science?
I mean, that may be the case, but I mean, the indispensability argument for the existence of numbers, straightforwardly, numbers do not play a causal role. And so that's usually not taken to be a devastating objection to the argument. So it's supposed to be some other type of role that's being played other than straightforwardly causal.
But here it might be causal.
I do think that ultimately we have to say something about the causal powers of the magnetite and all this sort of. That's a whole different story. I'm just going for the existence question, whether composites exist.
We're going to go next for 2 minutes. I started 2 minutes late. Who's number 5? All right. Well, Ken says it's enough. So
someone else take 5. Someone else take 5. That would more than 2 minutes.
Okay. Let's think of